Now, Ankita, you can start. Chakar sir is also here. Okay.
Okay, ma'am. I am
You can
sharing my
start.
screen.
Tell your ID then.
Ma'am, is it visible?
Yes.
So, good morning. My name is Ankita Rande, and my ID is 17003056. I am going to tell about arc voltage and arc interruption. So, first we will see arc voltage. So, arc voltage is the voltage drop across the arc. As we know that arc is purely resistive path, arc voltage will be in phase with arc current. As shown in the figure, the arc voltage is the square waveform, and the arc current, which is also called as short circuit current, is purely sinusoidal, and both of these are in phase. Next is arc interruption. So there are two methods of arc interruption. First is high resistance interruption, and second is zero current interruption. So first we will see high resistance interruption. So in this method of arc interruption, arc resistance is increased so as it will reduce the arc current to a value which will be insufficient to maintain the arc. And the arc resistance can be increased by cooling the arc, by lengthening the arc, and by splitting the arc. And when the current is interrupted, the energy associated with it will be released in the form of electrostatic energy, and the high voltage will appear across the contacts of circuit breaker. And if this voltage is more than the standing capacity of gap between the contact, arc will strike again. And hence, this method is not suitable for large current interruption. Rather, it is used for low power AC and DC circuit breaker. Next is current zero interruption, and this method is applicable only in case of AC circuit breaker. As in case of AC supply, the current wave passes through 0.100 times per second if the supply frequency is 50 Hz, and the current is not interrupted at any point other than zero current. And the current will also not allowed to rise again after zero crossing. There are two theories to explain current zero interruption. First is recovery rate theory, which is also called as Lapien's theory, and next is energy balance theory, which is also called as Cassius theory. First, we will see recovery rate theory. So, to extinguish the arc, the electrons and ions present in the gap are to be removed from the gap immediately after the current reaching its natural zero. So these electrons and ions can be removed either by recombining them into natural neutral molecule or sweeping them away by inserting an insulating medium. This insulating medium can either be gas or liquid, and the arc is interrupted by removing ion at a rate faster than the rate of ionization. So in recovery rate theory, as per recovery rate theory, in this method, the rate at which the gap recover its dielectric strength is compared with the rate of rise of restriking voltage. And if the dielectric strength is increased more rapidly than restriking voltage, then arc will be extinguished. Otherwise, that arc will be persist for next cycle. Next is energy balance theory. So in energy balance theory, as the space between contact contain some ionized gases immediately after current zero, and hence it has finite post-zero resistance. When the arc is extinguished, power becomes zero, and the gap is fully deionized, and its resistance is infinitely high. In these two limits, first power increases, it reaches its maximum value, and then again becomes zero. And due to the rise of restriking voltage and associated current, energy is generated, and this energy is generated in the form of heat in spaces between contact. And the circuit breakers are designed to remove this heat as soon as possible by cooling the gap. And if the rate of removal of heat is faster than the rate of heat generation, the arc will be extinguished. Otherwise, in opposite case, arc will persist for the next cycle. That is all about arc voltage, arc interruption, and the methods of arc interruption and arc interruption theories. Thank you.
Okay. Ankita, keep your video. Now stop sharing and keep your video on.
Sure, ma'am.
Ankita, do you have any problem related to theory or practical?
No, sir.
Okay, now you can leave the meeting.
Thank you, sir. Thank you, ma'am.
Next one is Ashish. Yes, Ashish Dinghi.
Ashish Denge.
Yeah, yes, ma'am. ID 17003014. Ashish Dengi.
Start your presentation.
Yeah, yes, 1 minute. Ma'am, I can't share the screen.
Why? Okay. Okay. You can speak then.
Protection, ma'am, I will talk on protection of parallel feeder.
Ashish, video on kar.
Mm, 1 minute, ma'am.
Okay. Now speak up. You have 2 minutes.
Yes, ma'am. Protection of parallel feeder. The parallel connection of a supply is mainly used for the continuity of the supply and for sharing the load. When the fault occurs on the protective feeder, the protective device will select and isolate the defective feeder while the other instantly assume the increased load. One of the simplest methods for the protection of the relay is the time graded overloaded relay with inverse time characteristics and the sending end and instantaneous reverse power or directional relay at the receiving end. We use two relays at the both ends. Where continuity of supply is particularly necessary, two parallel feeders may be installed. If a fault occurs on one feeder, it can be disconnected from the system and continuity of the supply can be maintained from the other feeder. The parallel feeder cannot be protected by non-directional overcurrent relays only. It is necessary to use directional relay at also to relay and also to grade the. We use directional relay at both the end or can be used at one end also. Each feeder has an your connection. Each feeder has a non-directional overcurrent relay at the generator end. This relay should have inverse time characteristics. Each feeder has a reverse power or directional relay at the substation end. This relay should be instantaneous type and operate only when power flows in the reverse direction. In the reverse direction at the relay end. Suppose an earth fault occurs on feeder 1, it is then the only one circuit breaker will operate open to clear the fault, whereas at feeder 2 the circuit will breaker will remain continuity of. In fact, the above arrangement accomplishes this job. Therefore, in parallel feeder, the power flow will be in normal direction, but it is reverse in directional relay, which is at the other end. In this
Okay.
way, we
Okay.
can
Okay, Ashish.
this. Thank you, ma'am.
Now keep your video on and turn shift your camera.
Yes, ma'am.
Ashish, do you have any problem related to practical or theory?
No, sir.
Okay.
No problem.
Okay. So now you can leave the meeting.
Thank you, sir. Thank you, ma'am.
Okay.
Yes. Yes.
Hello.
Next
Hello,
one,
ma'am.
Prajwal.
Hello.
Prajwal Nistani.
Hello.
Prajwal.
सर मी ललित बोलत आहे.
Okay.
सर माझ्या बहिणीचं कुंकू असल्यामुळे मला आता मी दिलं तर चालेल का?
Okay. Okay. No problem. Start sharing your topic.
ओके सर.
No.
1 minute. Sir, I am not able because of the range. I share my screen. Hello.
Okay. Then turn on your video.
Okay. Hello.
Okay, Lalit. You are visible now.
Okay. Can I stop? Because hello.
You have not written?
Yes, ma'am. I also return. I may. मॅम मी पीडी बनवलेली आहे पण इथे रेंज नसल्यामुळे म्हणजे आम्ही गावाला चाललेलो आहे ना तर रेंज नसल्यामुळे मॅम इथे नाही होत आहे.
हाँ, ठीक है, ठीक है, ठीक है. Speak up.
Yes. Lalit, am I audible to you?
हॅलो.
Lalit, start your presentation.
बोल तसाच. ललित,
हॅलो.
ललित बोल. You have 2 minutes.
मॅम सो माय today's topic is generator protection. Hello. Am I audible, ma'am?
बोल. We are listening.
Okay. For the conversion or the generation of the electric energy, the equipment generator is used. So it is widely ranged for different frequencies and voltage. As it is of the core conversion system, its security is also vital. So on the generator, depending on the generator size, different protection schemes are involved. Different protection size are involved.
हाँ, speak up. बोल. अरे बोल ना. Okay, Lalit. Lalit. Prajwal?
I'm
Start
sharing.
sharing.
Okay. 1 second.
Yes. तुझा आवाज मोठा कर.
Okay, 1 second, ma'am. Ma'am, today I am
हाँ.
going to tell about the topic of types of relays. There are 4 types of relays. First is instant current relay defined at many time. In order.
Yes. Now visible.
Is my screen?
Yes, visible.
Okay, ma'am. Uh, is a defined minimum time relay, which is also known as DMT. It is also time graded scheme. Each relay R1, R2, R3 that it operates for all faults in all the zones and provides backup protection to adjoint line form section operates in decreasing order from source. Ma'am, the advantage of DMT provides backup protection, and the another advantage is it is immune to the ratio of source impedance, that is Z1. The disadvantages of this relay are it is fault for a long period of time, and then they provide discrete. The solution of this problem is to use instantaneous high set unit along with definite time relay. And the application of DMT is mainly this scheme. This scheme is suitable for system where the impedance between the substation ZS is greater than ZS. And the third is inverse time over current relay. Inverse time over current relay. In this relay, if the relay R1, R2, R3 are inverse, then relays R1, R2, and R3, it's all the faults in own zone. You can see the graph, ma'am. The advantages of this relay is advantages of inverse time over current relays operates faster for faults in near the generator. That is near the source are operated in a fast manner by using this overcurrent.
Okay,
It also provide backup protection.
Yes,
Hello.
Prajwal. Now stop sharing and turn on your video.
Okay.
Yeah, turn on your video.
On, sir.
Okay. You are visible now. Do you have any problem related to practical or theory?
No, sir.
Okay. You can leave me. Now, next one is Namrata Dehankar. Yes, Namrata. ID 16003051. Yes, Namrata, am I audible to you? Next one, Aditi.
Yes, sir.
Okay. Start your presentation. You have 2 minutes only. Okay.
Hello.
Speak up. It is visible. Aditi, speak up. Aditi,
Hello.
हाँ
Hello,
अ,
ma'am.
हाँ बोल
Hello.
बोल बोल
Uh,
बोल.
okay.
2 मिनिटच आहे हा. Aditi बोल. Aditi,
Hello, ma'am.
अरे तुझा आवाज येत नाहीये.
मॅम मी बोलत आहे बट तुम्हाला ऐकायलाच नाही येत आहे.
ओके, नो प्रॉब्लेम. एक काम कर, तू व्हिडिओ ऑन कर आणि बोल.
ओके. ओके, स्टॉप शेअरिंग करते मॅम.
हं.
Ma'am, my screen is visible.
Yes, yes, yes. Uh, turn uh, turn your camera to the pages you have written.
Okay, ma'am. Ma'am, visible.
Yes, you can speak now.
A relay is an electrically operated. 2 minutes, ma'am. 2 minutes. A relay is an electrically operated switch. It consists of a set of input terminals for a single or multiple control signals and set of operating contact terminals. And relays use electromagnetism to convert a small electrical stimuli into a larger currents. Then we see a principle of the electromagnetic. Electromagnetic induction. Okay, in this there is an NC. NO means normally closed and NO means normally open. And when electromagnet is applied with some current, it induces a magnetic field around it. And above image shows the working of the relay, and in this there is a switch, and switch is used for the DC current. 1 minute, ma'am. To the load. In the relay, copper coil and the iron core acts as a electromagnet. Okay. When the coil is applied with a DC current, it starts attracting the contact as shown. This is called as the energizing of the relay. And when the supply is removed, it retrieves back to the original position. This is called as de-energizing of the relay. Then we see the induction cup relay, and hence the principle of the induction cup relay same as the induction motor. And this we see the diagram of induction cup relay. In this there is a four limbs, and this in four limbs are wounded by the coil. Okay, a stationary core is placed between these electromagnets as shown in the figure, and the rotating field is produced by the two pairs of coil wound on the four poles as shown in the figure. The rotating field induces the current in the cup, causing it to rotate in the same direction. The induction cup structure is more efficient torque producer because than the shaded pole or the watt meter structure. This relay is very fast in operation and has an operating time of less than 0.01 second. Okay, ma'am.
Okay. Do you have any problem related to theory or practical?
No, sir.
Okay. Now just turn that camera.
Okay, sir. Sir, I'm visible.
Okay, okay.
Hello.
Just adjust. Okay.
Okay, sir.
Do you have any problem related to theory or practical?
No, sir.
Okay. Now you can continue.
Okay, sir. Thank you.
Next one is Jay Shetty. Yes, Jay Shetty.
1810307.
Okay. Next one is Avinash Chimkar.
Yes, sir. Yes, sir.
Okay. Start your presentation. You have only 2 minutes.
Yes, sir. Just a second. Okay, sir.
Yeah, your screen is visible.
Yes, sir. I am going to share my topic named Method of Transmission Line Protection, out of which I have selected a topic time graded protection. Actually, there are three protection methods of transmission line. There are number one, time graded protection, number two, differential protection, number three, distance protection, out of which I am going to present time graded protection, under which the subtopic is parallel feeders protection system of the transmission line. It is the one which is overcoming the disadvantage of the radial feeders, which is the drawback of continuity of the supply cannot be maintained at the receiving end in the event of fault. Therefore, to overcome that drawback, the feeders may be installed in the parallel to maintain the continuity of the supply. Shows the figure shown in the sharing of the screen. It shows the two feeders are connected in parallel between the generating station and the substation. In this type of protection scheme, the feeder has a non-directional and the directional relay both installed in the two feeders respectively. The directional relay is installed at the receiving end, that means the load side, and the non-directional relay is installed in the generator side. If the fault occurs at the feeder 1, the fault current is fed by the two routes, that is directly from feeder 1 via relay A, and number B from feeder 2 via B and Q, substation and P. Therefore, only circuit breaker at A and P should open to clear the fault, and circuit breakers at P and Q of the feeder 2 should remain intact to maintain the continuity of the supply. Since the power flow in the relay Q is normal direction but is reversed in the relay P, this causes the opening of the circuit breaker P. Also, the relay A will operate while relay B remains inoperative. It is because these relays have inverse time characteristics, and current flowing in the relay A is in excess of that flowing in the relay B. Thus, the opening of the circuit breakers at point A and P, only the faulty feeder, one is isolated, and in this way the reliability of the supply is continued to the load side. Yes, sir.
Okay.
Okay, Avinash. Now stop sharing and turn on your video.
Yes, sir. Yes, sir. Yes, sir.
Stop sharing.
Say-
अरे वरती आहे त्याचे स्टॉप शेअरिंग.
Yes, ma'am. Yes, ma'am.
Avinash, do you have any problem related to theory or practical?
No, sir. No, sir.
Okay. Now you can leave the meeting.
Yes, sir.
Next one is Nakul.
Yes, sir. Am I audible?
नकुल.
Yes, ma'am. Yes, ma'am.
Now it's okay.
Ma'am, is the screen visible?
Yes.
Yes.
Hello, ma'am.
बोल ना.
Good morning. The topic of chosen is abnormalities in an induction motor, which comes under the application of switchgear and protection. As we know, induction motor is the most commonly used electrical machine in the industry because of its various technical and economical reasons. That's why it faces very much various mechanical and electrical stresses, which goes to which tends to abnormal conditions such as mechanical abnormal condition, electrical and environmental. Some of the abnormal conditions such as mechanical overloads, stalling, which is prolonged starting of motor, under voltage, unbalanced voltage, and reverse phase sequence, phase to phase fault, phase to earth fault, and single phasing. Now the abnormalities and choice of protection we chose to protect them, such as for mechanical overload in an induction motor, we use overload relays, thermal overload relay, overcurrent relay, MCBs with inbuilt trip. For stalling, which consume tremendous power from the supplies, we use thermal relay, instantaneous overcurrent relay. For under voltage, the under voltage release relay, under voltage relay. For unbalanced condition, which is very much dangerous for the machine and also for the supply, we use negative phase sequence relay for unbalanced voltage. For abnormalities such as reverse phase sequence, we use phase reversal relays. For phase to phase faults and phase to earth fault, we use HRC fuse, instantaneous overcurrent relay, and differential protection for more efficiency. For abnormalities such as single phasing, we use thermal overcurrent relay and single phase preventer. That's all, ma'am.
Okay.
Okay, Nakul, now stop sharing and turn on your video.
Yes, sir. Sir, am I visible?
No.
Sir, now?
Yeah. Now you are visible.
Okay.
Problem in theory or practical?
No, sir. No problem.
Okay. Now you can leave the meeting.
Okay, sir. Thank you, sir. Thank you, ma'am.
Next one is Raksha. Yes.
Yes, sir.
रक्षा.
Yes, ma'am.
Okay. Start sharing your content.
Sir, network problem मुळे share नाही होणार.
Okay. Try to turn on your video.
Visible?
No.
Differential protection is the best technique in protection. In this technique, the electrical quantities entering and leaving the protected zone. If the net difference is zero, it means no fault is exist. Differential protection is applicable to following parts of power system, that is generator, transformer, motors, buses, lines and feeders, reactors and capacitors. It provides high sensitivity, high selectivity. Differential protection is a unit type protection for a specified zone. It is very sensitive to the fault occurs within the zone of protection and less sensitive that fault occurs outside the protected zone. There are two types of differential protection, that is current and the voltage. Current differential scheme. Uh, if there are two sets of current transformers which are connected to either side of equipment, the ratio of the current transformers are so chosen. The secondary current of both current transformer and matches to each other in magnitude. Then there is a voltage balance differential protection. In this arrangement, the current transformers are connected in either of the equipment in such manner that EMF induced in the secondary of both current transformers will oppose to each other, and it is applied for feeders. Um, it's okay, ma'am.
Okay.
Okay, Raksha, do you have any problem regarding theory or practical?
No, sir.
Okay, just try to turn on your camera. Just try to turn on your video. Okay. Okay, Raksha, now you can leave it.
Okay, sir.
Okay. Next one is Revati. Yes, Revati Dajekar.
Yes, sir, I'm sharing.
Okay.
Raksha, you can leave.
Is it visible?
Yes, it is visible.
Okay. So I'm Revati Dhajekar with ID 170030001, and my topic is protection of induction motor. So as you know, induction motor is important component in an energy conversion process for electrical utilities. Hence, its protection is very essential. So the possible faults or abnormal conditions in induction motors are overloading, single phasing, phase unbalance, and short circuit, earth fault, or underload or stalling of lock rotor. So overloading, as the degree of overload increases, the heating effect also increases, which finally results in damage of insulation. And another fault condition is single phasing. This may occur because of down line or blowing out of fuse in line across the serious problems of induction motors. Then phase unbalance is when the three phases voltage supplied to the motor is not balanced with respect to magnitude. Then current are unbalanced in three phases. And the another fault abnormal condition is short circuit. Insulation failure due to shorting of any two or three phases of the motor is known as short circuit. So thermal overload relays protect the induction motor against this condition. Then another condition is the underload. Sudden loss of mechanical load and disconnection of conductor at terminal box create the condition of underload. Then again another is earth fault. The shorting of any one or more phases of the motor with earth because of failure of insulation is the earth fault condition. And against these all fault conditions, there are some protection schemes such as thermal overload protection. In this protection, this accounts for all thermal processes starting running at the normal overload conditions. Its function is to operate motor within its predefined temperature withstand limit, and the temperature is measured by thermistors. Second protection scheme is protection against unbalanced currents. The motor will draw the excess current because of single phasing, hence winding will be overheated. This may damage the rotor structure. So negative sequence relay is used. In phase fault protection, differential protection is adopted for small motors and overcurrent relays are used. In earth fault protection, it protects the motor against fault between one or more phases of earth. When neutral is accessible, instantaneous relay provides protection with setting of 20% of full load current. And in under voltage, when there is sudden voltage below rated voltage of the running motor current drawn by the motor increases. The under voltage relay gives protection against this phenomena. The typical setting range of under voltage relay is 70 to 100% of rated voltage. And next is loss of load protection. The usual practice is to use the definite time over current relay, which recognize the difference between no load before the application of load and no load after the application of load. So in this way, induction motor is protected against faulty conditions.
Okay.
Done, sir.
Stop sharing.
Turn on
Yes,
your video.
sir, visible.
No.
Sir.
Yes. Now it is visible. Do you have any problem in practical or theory?
No, sir. No problem.
Okay. Now you can leave the meeting.
Okay, sir. Thank you, sir.
Next one, Samkit Sangai. Yes, Samkit is there.
Hello. Hello.
Yes. Okay, okay. You are audible. Start your presentation. You have only 2 minutes.
Yes. Sir, screen visible.
Yes, visible.
So, sir, my topic is relay and its properties. So, sir, I will tell about relay. Relay is a sensing device. This will sense the abnormal conditions such as short circuit fault in the system and give the tripping signal to the circuit breaker. So there are some terms used in relay such as backup relay. A backup relay acts as a second line of defense. A backup relay operates after a slight delay if the main relay fails to operate. The primary relay protection. The primary relay is the first line of defense. It will operate. It is supposed to operate at the instant of the fault, and it acts as a first line of defense. Then the stability, the ability of a protective system to remain inoperate, operative under the load conditions, and also case of the external faults, the relay should remain stable when the heavy current due to external fault is flowing through it. So means stability is the ability of the relay to remain stable even if there is a external fault in the system and heavy currents are flowing in the system. There is a pickup level. The value of actuating quantity above the relay will operate. It can be current if current transformer is used and if potential transformer is used, it will be voltage. The reset level is the value of actuating quantity. The minimum actuating quantity if the means if the current or voltage falls below that level, the relay will de-energize. Then, sir, there are some properties of the relay. Uh, the properties of relay are speed of operation. The speed of operation, the relay should means the relay should operate as quickly as possible to means isolate the fault from the faulty zone. Even a slight in the operation can cause thermal and mechanical stress on the healthy system. The sensitivity, the protection of system should be able to detect the minimum possible value of the fault current and issue a signal to the circuit. So this is called sensitivity. And reliability means it is the assurance that the protection system will perform 100% correctly. It mainly depends on the two factor dependability means it should operate when it is supposed to operate, and the security, it should not operate when it is not required to operate. And then the system simplicity is one of the factors that is taken into account, means that the protection system should have minimum number of equipment and associated security achieve the protection objective. Means simplicity means that a minimum number of systems should be used to achieve the required security, And then stability. Stability of the system means, as I already told, that even if the fault currents are flowing in the system, it should remain stable. And the last is economics, that the system which we are using should be in the cost, should have minimum cost. So, sir, these are the properties of relay.
Okay, stop sharing. Sankeet.
Yes, ma'am. Go.
Stop sharing, Sankeet.
Ma'am, I stopped. Ma'am, is it visible now also?
हा थांबून जाऊ, लॅगिंग आहे बहुतेक ते थोडस, काय प्रॉब्लेम नाही. तुझा व्हिडिओ ऑन करून दे.
Oh, hello. Now, am I visible?
Yes. Have you stopped sharing?
Yes, ma'am.
Yes, okay. Samkit, do you have any problem related to theory or practical?
No, sir.
Okay. Now you can leave the video.
Thank you. Thank you, ma'am.
Next one is Sejal Dahibar.
Yes, sir.
Okay.
I will start sharing, sir. Is my screen visible, sir?
Yes.
Okay. Sir, so I have selected the topic overcurrent protective scheme. The overcurrent that relay operate and closes in its contact when the current exceeds predetermined threshold value. Cup threshold is defined as the value beyond which the relay operates. Now the overcurrent indicates there is a specific limit that is specified to the current. When it exceeds that threshold limit, our relay starts operates. And now the overcurrent relay is specified into four different kinds. First of it is instantaneous overcurrent relay. This operates instantaneously without a time. As soon as the pickup value is crossed, the relay operates immediately within 20 to 40 milliseconds. Now this instantaneous, as its name suggests, it acts instantaneously when it crosses specific limits. Now it can't operate in zero time, as nothing is ideal. So it takes 20 to 40 milliseconds, which is considered as pretty zero time. The next is definite minimum time relay. Definite time overcurrent relay is a relay that operates after a definite period of time when pickup value is crossed. Time setting ranges from 0.1 to 1 seconds to from 1 to 10 seconds. Now this definite minimum time relay, we have to set up a definite minimum time, that the minimum time that the relay should operate, which is between 0.1 to 1 seconds. And the next is inverse time overcurrent relay. In this, the time of operation is inversely proportional to fault current. Operated the fault current, the relay will operate in more or lesser time. Now in inverse time overcurrent relay, in here, now if the fault occurs pretty quickly and for more frequency, the reaction time of relay will be in such way that operates inversely. And the next is definite minimum time overcurrent relay. Widely used in the field. When the current become very high, it follow definite minimum operating time pattern. Initially, it follow inverse low, then high current, follow definite minimum time operating time. That's it, sir.
Okay. Now stop sharing.
Okay, Sejal, turn on your video. What is your ID?
Am I visible?
Yes, you are visible. Your ID?
1700302.
Okay. Do you have okay? Do you have any problem in practical?
Am I audible, sir?
Okay.
Okay, you can leave the.
Yes, sir. Thank you, ma'am.
Okay, next one is Sominath Harne.
Sominath.
Let me know my screen is visible. I'm
Yes,
audible.
yes, visible. Speak up.
I have choose the topic. There are two methods of the art and one. We use the lengthening the arc, pulling the arc by means we are putting the resistance to the arc. Here I am explaining that the resistance theory. The arc is of the ionization of the gas. To extinguish the arc, the electrons and ions to be removed from the gap. The electrons can be removed from either the recombining them or by sweeping them out from the gap. The arc is interrupted if only electrons removed from the gap and recovers the dielectric strength as compared to the rate of restriking voltage. If the rate of restriking voltage is more than the rate of dielectric recovery, then arc is again formed for the half cycle. Here in the gap, we also see that if the dielectric recovery is more than the restriking recovery, then arc is interrupted. And if the dielectric recovery is less than voltage recovery, then dielectric failure is the happened. It happened at every current zero. There is it called the race theory. It is the race between dielectric recovery and the restriking voltage. Therefore, it's called the race theory. And the last thing, race theory is also called as Laplacian theory. That's it.
Okay. Okay. Stop sharing.
Turn on your video.
Am I audible?
Yes, you are visible. Do you have your practical? Okay, you can leave me. Now, Jayesh or Namrata?
Yes, sir.
Okay, Jayesh, start sharing your content.
Yes, sir. Yes, sir. One minute, sir. Hello, sir.
Yes, you are audible, Jayesh.
Sir, PDF is not getting me. So let me find it and then I will share. So is it okay? Next, I will
No, you turn on
speak
your
after
video
now.
and start your.
Okay. Okay. I am visible, ma'am.
Yes, you are visible.
So the topic I am going to explain today was the current transformer. So basically, current transformer is nothing but it is used for the measuring of the currents in system, just to lower down the higher currents to measurable quantities, and it has a primary winding and secondary winding. Primary winding has fewer turns to carry the higher current, because the high voltage system has very high current which cannot be bearable by our ammeter, normal standardized ammeter. And for that, for this kind of things, the current transformer is being used. And in the secondary winding of current transformer, the ammeter is connected, and it has standardized the rating as a 5 ampere or 1 ampere. And by step downing, the current is being measured by the ammeter. And it has advantages like that. It can measure the very high capacity current without damaging the emitter. And measuring instruments are being isolated from the actual system, and it can sustain the high voltage capacity. And it has a very few disadvantages also, that it cannot be used in a DC system. And it may require the heat sinks for the for the kind of thing that current is being very high kind of capacity. And it has drawbacks, that it cannot be used in DC. And its application is a differential protection system, a time graded protection system. The current transformer is required. So this was to explain, but my PDF is not visible. Done.
Okay, okay, Jayesh. Now, do you have any problem in theory or practical? Okay, now you can leave the meeting.
Okay, ma'am. Thank you, sir.
Next one is Namrata.
Sir, am I audible?
Yes, you are audible. Start your presentation. You have only
Yes.
2 minutes.
I'm starting. Sir, is my screen is visible? Hello,
Yes,
sir,
Namrata.
is my screen is visible?
No.
So, sir, I'm sir, my
Okay,
video.
turn on your video.
Sir, am I visible?
Turn on your video. You are not visible.
Sir,
Yes.
sir,
Okay.
is I am visible?
Yes, yes, you are visible. Now start your presentation. You have only 2 minutes. Okay.
Sir, is it visible? Sir, is it visible?
Yes, it is visible.
So my topic is air brake circuit breaker. Air brake circuit breaker are quite suitable for high current interruption at low voltage. In this type of circuit breaker, air at atmospheric pressure is used. An arc extinguishing medium. It employs two pair of contacts. That is, one is main contact and second one is a arcing contact. The main contact carry current when the breaker is in close. They have low contact resistance. When contact are open, the main contact separate the first, and arcing contact still remain close, and that's why the current is shifted from main contact to the arcing contact. The arcing contact separate later on, and the arc is drawn in between them. This is a diagram for the air brake circuit breaker. In air brake circuit breaker, the principle of high resistance is employed for arc interruption. The arc resistance is increased by lengthening, splitting, and cooling the arc. The arc length is rapidly increased, employing arc runner and arc chute. The arc moves upward by both electromagnetic and thermal effects. It moves along the arc runner and then it forward into chute. It is split by arc splitter. A blowout coil is employed to provide magnetic field to speed up arc movement of direct the arc into arc splitter. The blowout coil is not connected to the circuit permanently. It comes in the circuit by arcs automatically during the braking process. The arc interruption is assisted by current zero in case of AC breaker. Circuit breakers. High resistance is obtained near current zero. It is used for high current interruption at low voltage, suitable for voltage range from 400 volt to 1200 kV. Sir.
Okay, Namrata. Camera.
Okay, Namrata, now turn that camera towards yourself. Do you have any problem in theory or practical?
No.
Oh,
Sir, am I visible?
1 minute. One minute, Namrata.
Yes, ma'am.
1 minute. नहीं नहीं इतनी जल्दी नहीं थी मैंने हाँ कल ओके नम्रता
Okay.
ओके
Thank you, ma'am.
ओके
Thank you. Thank you, sir.